Okay, I'll be working problem 933 from the book, and this problem is asking to find the centroid y bar, or the distance in the y direction from the origin to the centroid. So I have the graph drawn, and this is the area given. It's like a parabola. And then our centroid is right about here. Next to it I have the centroid's location is called x squiggle, comma y squiggle. And that is actually x squiggle, comma y squiggle equals x, comma y over 2. So, to find how far the centroid is in the y direction from the origin, we'll use the equation y bar equals the integral of y squiggle dA over the integral of dA. Alright, and first we will look at the numerator, and so the numerator is the integral of y squiggle dA, and that is equal to the integral from 0 to a pi of y over 2 y dx. And we did this because up here we defined the centroid as being at the location x, y over 2, which means that y squiggle equals y over 2. So we use that to rewrite our numerator so we can solve it. And we are integrating from 0 to a pi because that was the distance given in the x direction. So now we will solve it. And this is equal to 1/2 the integral from 0 to a pi of a sine x over a squared dx. So far all we've done is taking out the 1/2 from our integral, since it's y over 2, and then we need y in a form that we can solve it like in terms of x. And in the problem we were given that the equation of the line equals y equals a sine of x over a. So that's what we have here. And since it's y over 2 times y, it is squared. So now we can simplify that a little more, and we get a squared over 2 times the integral from 0 to a pi (1/2) 1 minus cosine 2x over a dx. Take the 1/2 out again, and we get a squared over 4. Integrate the middle, and we get x minus a over 2 sine 2x over a from 0 to a pi. And this is equal to a squared over 4 times a pi plus 0 minus 0 plus 0. That just leaves us with a cubed pi over 4. So, since we have that the numerator is equal to a cubed pi over 4, now we just need to take a look at our denominator, which is the integral of dA. So, we saw on the previous page, let's rewrite the equation for the centroid. Y bar equals the integral of y squiggle dA over the integral of dA. We solved the numerator to be a cubed pi over 4. So now we need to look at the denominator. So the denominator is the integral of dA, and dA is the same thing as y dx. So we can rewrite this so that we can solve it as the integral from 0 to a pi of y dx. So now all we have to do is rewrite y in terms of x. So we get the integral from 0 to a pi of a sine x over a dx. So now all we have to do is integrate, and we get negative a squared cosine x over a, and all of that from 0 to a pi. So now we can take that a little further, and we get negative a squared times negative 1 minus 1, and that leaves us with 2a squared. So now we are given the numerator, which we found to be a cubed pi over 4, and we just found the denominator, which is 2a squared. So since we have both the numerator and the denominator solved for, all we have to do is plug it back into our original equation for y bar and solve for y bar. Just take it down here and say if y bar equals the integral of y squiggle dA over the integral of dA, integral of y squiggle dA equals a cubed pi over 4, and the integral of dA equals 2a squared, then y bar equals a cubed pi over 4 all over 2a squared. So then y bar equals a pi over 8. And that's our problem. Thank you.